Hi, everybody, and thank you for joining today's webinar, Technical Considerations and Planning. This is a special 1-hour webinar that is part 4 of 4 in the IBM Cloud Pak for Automation webinar series. If you'd like to watch any other parts in the series, head over to integra.com to view all of our webinar recordings. Just a couple of reminders, please submit any questions you may have throughout the webinar in the questions box of GoToWebinar. Also, be on the lookout for poll questions so you can cast your vote. And finally, there will be a brief survey at the end, and we'd love to hear your feedback. Now I'll hand it over to Scott Burt to introduce today's speakers.
Hi, everybody. Thank you very much for joining us. We value your time and attention, and we know how busy you all are, so thank you for joining us. This will be a 1-hour presentation, a special one, longer than our normal half an hour, and we are thrilled to have 2 amazing speakers here joining us today, and we went right to the source with Kevin Trinh joining us. Kevin is with the development team with IBM in the DBA, Digital Business Automation Group. Kevin has been with joined FileNet back in like 1998 and has been in the development group and various organizations ever since then. And he is currently the architect for IBM's FileNet container strategy and for the DBA platform. And Kevin, if I butchered that, you can clean it up or correct it in a little bit. But I've heard Kevin speak, and I just he's super sharp, and I'm so glad to have Kevin give his time here to join us and share direct from IBM. Martin Willingham is our own senior FileNet consultant and been with us for a number of years already. Martin, interestingly, was a customer first with a large FileNet client, clear back in what, 1996, I think, Martin. And after that, went and joined FileNet and then IBM in the consulting practice, helping large organizations implement and benefit from the IBM and FileNet content solutions, and is now happily here at Integra, is helping us delight our clients with these kinds of products. So thank you very much both for joining us, and I'm going to hand it off to you both.
Okay, this is Martin Willingham, and this is the 4th in a 4-part series on Cloud Pak for Automation. We've talked about kind of the overview of what Cloud Pak for Automation brings. We've talked about the process automation part and the content. And today we're talking about the nitty-gritty on how to implement it and how to choose where to put it, what type of deployment choices you have, and what's the best way to decide on how to do that. So we first have a survey to kind of get started. Lindsay, can you pop that survey up? So the question is, where are you in thinking about container and Kubernetes technologies in your organization? And the first choice is deployed in production. Next is deployed in some sort of pre-production environment. Maybe you're just planning, or maybe you just think this is flash in the pan and you're going to wait and see how everybody else does it before you start going down this path. So if you could choose. Lindsay, has everyone? Okay, great. Not a lot of production use, but definitely some people are thinking about it. That's great news. Okay, so today Kevin's gonna be doing most of the speaking, but I'm gonna be asking him a few questions. Kevin, let's say we're talking about a new customer to FileNet, or maybe someone who's looking to upgrade their traditional infrastructure to the next version. And they're thinking about Kubernetes, they're thinking about containers, they're thinking about cloud, and there's a lot of choices out there. So I guess the first question would be, how would you choose between cloud versus on-premises?
That's a great question, and we have a lot of customers that are kind of in that situation themselves as they move towards a cloud-based and cloud-native type of deployment. And so really, a lot of the time, these customers are dictated by really their IT cloud type of architects and strategies. And so we normally only see customers move to public cloud because they have a strategy to move towards a public cloud deployment in order to, for example, reduce costs, reduce infrastructure footprints, and reduce their data centers, and gain agility in towards adopting cloud and being more flexible by being agile in the cloud. But if those customers or our existing customers don't have that strategy, they tend to stay on premise, and they'll move towards a modernized platform like Kubernetes and containers on premise versus moving towards the cloud.
Great, that's very helpful. So speaking of that, if they were going to stay on premises, or if they were going to build out an infrastructure in the cloud, how would you recommend they choose between a traditional VM infrastructure versus containers and Kubernetes?
So definitely from an IBM perspective, our strategy is to move towards a more cloud native type of deployment model. And so you'll notice that a lot of our capabilities that we build out is going to be container first. And that's very so true from a Cloud Pak for Automation perspective. All the new capabilities that we build for the Cloud Pak for Automation platform is container only and or container first. And so that's our strategy. And so if you want to be part of that journey with us, then definitely adopting containers and Kubernetes is the initial step for you to do that. A lot of our customers are moving away from traditional VMs because of the cost savings, the ROIs, and the DevOps capabilities that containers and Kubernetes provide. So definitely our strategy forward is container first.
Nice to know. So get on the train, or you're going to get left behind, it sounds like. Okay, so if they want to, now they decide, okay, we'll go down the Kubernetes path. Now we hear about OpenShift and some other similar ways of deploying Kubernetes, but what about Amazon EKS and Azure and IBM and cloud? They all have their own Kubernetes service. How would you choose between those two kind of themes?
That is definitely a great question. We have a lot of customers that are trying to make that decision themselves. From an IBM perspective, we are Red Hat and OpenShift first, right? And so from a deployment and a software perspective, we are very opinionated in favor of OpenShift, whether that's being on premise or offering in our cloud, like for example, IBM Cloud, Red Hat OpenShift Kubernetes service, or even Azure managed OpenShift, right? So we prefer OpenShift first. Now, when it comes to public cloud and customer who adopts public cloud, typically what the trends that we are seeing is that the reason why they want to be able to go and adopt public cloud is because they want to be cloud native in those specific public cloud vendors like AWS. And that means that they have standardized on services that are offered by that public cloud. So I have one customer who is moving towards public cloud, and they are only able to use services that are a catalog in those public clouds. And so that means that running EKS is the directions that they'll go with, is because that's what their DevOps team and their IT team has blessed as being compliant and meets their standards from a services perspective. And so definitely when we talk about public cloud, being cloud native and using native services is one of the main driving factors for that decision from a customer perspective.
But as far as functionality, all of those FileNet will run perfectly fine on any of the Kubernetes environments, right?
Correct. From a FileNet container perspective, even from a Cloud Pak perspective, we just require that you are running on a certified Kubernetes platform.
Nice. Okay, thanks. Okay, the last question, and I know it's the bulk of the question, is can you describe a typical project Maybe a customer who has FileNet already and they want to upgrade, they want to move to containers. It's not too hard to just start out a new project with a brand new FileNet system on containers, but moving to containers from an existing deployment in a VM infrastructure, maybe on premises. How do you go about that? What does that process look like? I know there are a lot of requirements. There's storage needs, backups, DR, a lot of best practices. Can you kind of describe that?
That is a great question, Martin, and it just so happens that I have a whole slide deck on that. So I will take you through that journey and understanding what that is. And since this is an IBM slide deck, there's just some legal disclaimer about what we talk about here. But definitely, we can explain this by going through an actual use case. And so this whole journey here is based off of this customer called Insurance United. And they've been a long time FileNet customers. They have FileNet running in productions for quite a while. And so one of the things that they wanted to do as part of this journey is to modernize their FileNet platform as well as modernize their application. So they had this insurance claim called vehicles claim that they want to modernize, and as they also modernize their FileNet platform. And as part of this journey, they want to move to Red Hat OpenShift. So this is purely all on-premise, right? And so they have an existing production environment as well as a dev and test environment. And here are kind of the background information in terms of what they have in place. So we also have information about how many cores they have for each of the CPEs and how many cores they have from a navigator perspective, the number of documents that they have, or the total size of the documents they have, and the storage appliance that they're currently using. The database backend is an Oracle 12c and a Microsoft Active Directory. So pretty typical from a FileNet customer perspective. Most of our customer has similar production environments. They're varying in size and potentially different database or active or different LDAP backends. They definitely have other integrations that are tied to the FileNet deployment, similar to this vehicle claim application. So how do we get started? So essentially, this journey entails into multiple phases. And one of the first things that we want to understand, even from a customer, or even from our services team or partners like Integral here, that how do you approach this? So we broke it up into 3 specific phases, which is the discovery, planning, and execution. And essentially the discovery phase is purely just trying to understand what you currently have and how things are pieced together and how things are integrated. And then the planning phase is trying to understand where you want to move to and what we need to do from a design and architectural perspective. And then finally, once we have all that understanding, how do we actually execute, right? So let's go through the discovery phase. The discovery phase is that we need to understand what the initial requirements is, right? So definitely adopting Red Hat OpenShift was a given, right? You want to modernize the FileNet platform and take advantage of the capabilities of the Kubernetes platform, gain better resiliencies, gain DevOps improvements, efficiencies, as well as gaining better resiliencies and high availability that the Kubernetes platform like OpenShift provides. You're going to transition to a FileNet container, so take advantage of the container and Kubernetes platform. The part of the other thing is that you also have an opportunity to look at how do you modernize your existing custom applications, right? Definitely there has been shown significant business value in modernizing your custom applications to a container base and leveraging automations, CI/CD pipelines, and integrating that with OpenShift. So definitely there's a huge business value on doing that. There's actually an assessment that it has shown significant improvements in cost savings from a DevOps perspective, as well as from your developers' perspective, in moving towards a container base and adopting OpenShift. The other part of it is that you have not all applications and solutions can be modernized all at one time. And that's very typical of our FileNet customers, where they have a large deployment of FileNet that are servicing multiple lines of business, custom applications, and other solutions. And those development resources are potentially not the same resources for all the applications. And so how do you be able to stage and stagger these migrations so that you are able to support lines of business and solutions that are able to modernize on currently, and then be able to move those other and modernize those other applications later on? The other part of it here is they currently don't have CSS in place or content services, and then you want to be able to adopt that. The other part of it is they want to also implement an application service layer, essentially, which is trying to make it a generic service layer where they can write custom applications, which doesn't necessarily tie to a specific vendor application API like FileNet, and abstract that out. So a lot of our customers uses DataPower or MuleSoft to abstract out those API layers and write custom applications against that generic tier, and abstract out the underlying application-specific APIs. So that way they gain agility to move things or move pieces and upgrade versions without impacting their overall custom application development. But this is a stretch goal, right? So it's good to understand and know that what needs to be happening now as part of this initial migration is what we can defer to a later stage. The last point is they're on an old storage appliance, which is EMC Centera. And so EMC has a new modernized version of their storage appliance, which is Elastic Cloud Storage, or ECS. So they plan to move to that. So that's the kind of basic requirements, right? And this is what their current architecture looks like. This just so happens that this is actually, the architecture diagram of this one is actually one of our customers that aligns with the whole scenarios. And so this probably looks kind of familiar to you as well. And so on the left-hand side is their existing production environments where they have Navigator and CPU deployed in TWAS. And then they have a storage Centera device that they currently have attached to. And then on the right-hand side is their DR environment, right? So very typical. In your FileNet environment probably looks kind of close to this as well, right? So we're going to look at how do we modernize this into Kubernetes, OpenShift, and containers. So here's the current state in their current production environment. And so this is also very important because this kind of gives us a good picture of, okay, well, how do we approach the migration? And how do we architect a new platform that they're planning to move to? So we've already know that they have Microsoft Active Directory. They're using an Oracle database as the backend. The FileNet deployment consists of CP4A. They have 4 object stores. And each of those object stores serves a different lines of business. And then, which is also a key data point, right? In terms of how we approach this migration. And then they also use Content Navigator. And then each of those lines of business are segregated by different Navigator desktops, right? And then on the right-hand side, we have the current sizing and the current utilizations. And this information is going to be key in terms of how we approach sizing for the new environment. Now we get into a little bit more details of how the application works and how everything fits together from an integration point, because this also has an impact in terms of all the connectivities and how users are going to be leveraging the system, how they log in and access the applications, right? And then this also has an impact in terms of what changes we need to make from the custom applications perspective, and potentially how do we address the common service layer that they're looking to do, right? And so The vehicle's claim application has a customer portal. And that customer portal calls the content platform engine API to launch a simple workflow. And so we know that they're leveraging some of the out-of-the-box workflow capability, not necessarily pure case foundation or case manager, but a simple workflow that is offered as part of out-of-the-box. The customer gets a status, upload documents, and collaborate on the claim through the customer portal. So they're definitely working around a lot of the UI piece and working with the documents, right? And then the key point here also is that they are stored in their own designated object stores. The custom application is deployed on WAS within the same ND cell as the found application. So we definitely know that potentially this custom application is using the EGB interface for the custom application to be able to talk to CPE or through the CPE Java API. So that's something that we need to be aware of. Claim adjusters and other internal members use Content Navigator to work on those documents, right? And so the customer comes in this custom application, their customer portal, but internally, all the adjusters and all the people that needs to work on this claim goes through Content Navigator. And again, this pertains back to a specific Navigator desktop that ties to this object storage, right? The other part of it here is that they also have a separate system where they store the customer data or the customer accounts information. Very typical of insurance or even banking customers, right? They have a back-end system where they store all the customer information. And so in order to query those customers, they have a custom plugin in Navigator that helps to facilitate that and do those mappings between the insurance claim and what information gets passed and mapped to into the FileNet system, right? So all these things are critical information in terms of, one, how do we plan for this? What changes needs to happen? And how do we architect a new system, right? Getting this data will help us understand and formalize a good approach for this. So once we've done with the discovery phase, we gather all those data and all those deep information in terms of how their existing environments are, their integrations, their custom applications. Now we need to understand what their desired state is, right? This is going to also help formalize the overall requirements, right? And so they want to deploy it on OpenShift. That's a pretty given. They want to modernize the FileNet platform, so moving towards OpenShift. Content search services is a new component that they want to deploy, and they don't have that in-house already. So this is something that they want to add on capabilities to be able to search those documents and be able to leverage and gain more insights on those documents that the customer uploads. The custom application will need to be containerized and deployed on OpenShift, right? So they have an existing Java application that deploys on traditional TWAS or traditional WAS, and then potentially modernize that in terms of containerizing and how do they do that. Then, of course, the service layer for the custom app integration. And just keep in mind that last bullet item or desired state was given to us that it was a stretch goal, right? All right, so we understand what the desired state is or what the requirement is. Now we take a look at the timeline. This is kind of ballpark, right? And depending on really the details will dictate how much of this stuff that will fit into this. But this is a pretty simple, straightforward migration, right? And so give or take a couple of weeks or days, this is just kind of a ballpark. Design. We're talking about re-architecting a new deployment model. of the Faunet software onto OpenShift, right? So it's a totally different architecture than traditional VMs and WASMD, right? And so we have to take a look at how do we approach the new architecture and what changes we need to make in order to support moving their existing Faunet deployment and being able to access the existing data, right? And then how do we approach modernizing the custom application that they have? And then there's some licensing aspect we won't get into here, but the other part is how do we size this new environment, right? Since we're talking about a new architecture or new deployment model, the sizing that you currently have in place for that you have in production potentially might not necessarily match with what we do from an OpenShift perspective, right? And so that's the other large aspect that we need to take a look at. So let's start off with OpenShift. OpenShift is a Kubernetes platform by Red Hat, right? And so this is our preferred platform for deploying Cloud Pak for automation, as well as from a Faunet content manager perspective. But it's totally different than what you potentially are used to, right? The architecture for OpenShift or Kubernetes in general is nowhere close to alignment in terms of what you're used to from a WASMD and a traditional VM perspective. So there's a couple key pieces that are important, right? The masters, the etcd, the infrastructure, and the application nodes. Each of these things serves a different purpose. The master node is responsible for all the API endpoints, the scheduling, and the backplanes of the overall Kubernetes platform. The etcd is the configuration data of the key value paired component that stores all the cluster information, the cluster configuration, where it gets deployed, and everything else. The infrastructure nodes are essentially there to serve other services that OpenShift provides, like, for example, the container registry, the routes, and the proxies. The application nodes is essentially where you run your workload, right? So the Faunet workload that you deploy, those runs on the application nodes. All these pieces also have implications on how you do HA as well as how you do DR, right? And so having a good understanding of the overall architecture will also drive in terms of the design and architecture for high availability, as well as how do you approach DR on this new architecture. So from a master's perspective, right, in order for you to have high availability for the masters, you need 3 master nodes, right? And the reason why there needs to be 3 is the way how masters are servicing or provide HA, right? You usually only talk to one of the master nodes, and they elect a master that you talk to. And that's the reason why there's 3, because it's based off of a quorum base. And typically masters or a quorum based type of architecture requires odd numbers, right? So that way there's a tiebreaker in essence, in order to make sure that they're not trying to compete for who becomes or elected to be the master. That's also the case with etcd. Etcd requires a quorum, which also requires 3 etcd nodes in order to provide HA. The infrastructure node, you get HA by deploying multiple nodes of the infrastructure node. So that way, sorry, I have a bunch of meetings that are coming up. Let me close that. You just have multiple nodes for the infrastructure, and then of course the application nodes, you would have multiple of those to deploy multiple pods of our applications. The other part of it is how do you handle storage? Kubernetes and OpenShift handle storage differently than you do with traditional VMs, right? Traditional VMs, you just attach storage, like for example, in this case, Centera. and you dedicated storage volumes to those VMs so that you could connect to those and whatnot. Well, the way Kubernetes and OpenShift handles storage is a little bit different. You have to tie it to a persistent volume, and there's different storage plugins that you use in order to attach to those storage, like for example, NFS plugins, right? You need to create a persistent volume, and then you expose that through persistent volume claim to an application. And so definitely, as we transition from a traditional on-prem perspective and attaching existing storage that we were using to store content for FileNet, we need to reattach those to Kubernetes and expose that through a PV and a PVC so that CPE can access those existing data. So that's also very key, right? Especially when we're talking about migrating from an existing on-premise environment to a container base. Security is a big paramount in when you look at OpenShift or Kubernetes in general. It has a lot of flexibility as fine-grained control in terms of security around network policies, as well as RBAC roles to access resources, right? In OpenShift, and later on, when we go deploy FileNet or even CP4A, we add in network policies to tie down access to our application. And then you also have the ability to modify those security policies for access. The other part of it also is that OpenShift is probably the most restrictive in terms of deploying and running applications in a Kubernetes environment. They have this concept of security constraint that applies to a namespace or overall cluster that dictates how those containers behave, right? And so it's important to understand how security impacts your OpenShift cluster as well how you deploy applications. We already talked about high availability, right? All the pieces that we need to do from a high availability perspective. The nice thing about storage and database and LDAP is that it doesn't change. We just need to make sure that we attach those things correctly so that you can connect to those pieces or those external services in a highly available manner. Disaster recovery. Not a lot of things will change from your disaster recovery implementation or strategy perspective, right? The only thing that you need to worry about now is that how do you do DR for OpenShift? And there's a couple ways for you to approach that. The key point here is that if you had to go and replicate and rebuild an OpenShift cluster, what do you need to replicate? Essentially, it's the etcd, right? The etcd data is what stores all the configuration information for the cluster as well as what gets deployed. Now, you also have the ability to do more advanced DR, like running active-active, and there's ways for you to do that with OpenShift as well, right? So that's from an OpenShift perspective. And essentially, this is what it looks like from an architectural landscape perspective. And you'll notice here that OpenShift uses an SDN, a software-defined network, or a private network that it builds in order to tie in all their pieces as well as accessing all the applications that gets deployed. And this is also the reason why where simply deploying applications onto OpenShift or any Kubernetes platform, you can't really access it at all unless you expose a route or an ingress in order to access this application, because it's all sitting behind a private network. And then all those applications and all those nodes have the ability to do outbound or egress traffic. You can tie those down more tightly through network policy, right? And so definitely in terms of security, you're going to gain more security controls or leverage more security controls than you would in traditional VMs where you have to relying on network firewall rules and policies. Here, you can even tie that down further from a cluster level perspective. All right, so now we get over to the FileNet side. So we have kind of had a good planning phase for how do we architect the OpenShift. But now we've got to look at how we do it from a FileNet perspective and running it on OpenShift. The key thing here is that they want to be able to migrate to OpenShift platform or containerized platform and still be able to do it in phases. Because again, if we go back to understanding what their current state and what their requirement is that they can only modernize and migrate one of their applications, which is the vehicle claims applications, to the OpenShift platform. And they had 4 solutions because they had 4 object stores. So they had 4 custom applications solutions in total from a FileNet perspective, but only one of those can move over. So how do we approach this? And so that means that what we want to do is run a parallel environment. And so this is one of 3 migration strategies to containers. And so a parallel environment is one of those 3 core migration strategies. And it gives this parallel environment gives you the flexibility of moving custom applications and solutions to a container platform at a more scheduled pace, where your custom applications and your line of business can move over there when you have the resources and capabilities to be able to transition over that platform, right? And so in this scenario, we're going to run a parallel environment. And the requirement for running a parallel environment is that your on-premise environment, a FileNet, has to match the version that you're deploying in OpenShift. And luckily, in this customer scenario, they're running version 5.5.1, which was the first release of our container platform or container support. And so that means that they don't have to necessarily upgrade to the latest version, which is 5.5.4 for CPE or P8 and Navigator 3.07. They can stay in their current version and be able to migrate and run a parallel environment with OpenShift at the same time. The other important thing in here is that we want to be able to access the existing data. So that means that when we go deploy FileNet, containerized version of that platform, we want to make sure that we point to the existing database, the existing content storage, as well as the existing LDAP. So that way, all the data that they had in place are still accessible, and be able to continue to process those work by going through the new platform. The other one thing that we need to do is, since they're using Centera, and most likely they were using a fixed content device, the FileNet container platform doesn't support or doesn't have the SDK for EMC Centera, but only for ECS, which is the newer version of EMC storage appliance. So that means that they will need to migrate their storage from EMC Centera first to ECS before we can adopt or move to a containerized platform, right? And then lastly, CSS. And the reason why we kind of added CSS in this picture is really to show the difference between the architecture for traditional base versus container base. And the way CSS works is different from on-premise versus containers, is that in order for us to deploy and be able to support high availability for a CSS perspective is having a good understanding of how that load balancing works, right? CPE handles the load balancing for CSS. Even though you might have a whole bunch of CSS instances up and running, it doesn't really matter, because what really gets load balanced is how CPE gives work to CSS. And that's the key part, right? And this is also a reason why on traditional on-premise, you can't tie or front a bunch of CSS instances in front of a load balancer. You go register each of those instances in CPE, and you configure them to do either search or indexing, right? And typically best practice is that you would have pairs of CSS that handles indexing and pairs that handles CSS searches. You can definitely configure for them to do both, but that also has workload and performance implications. Now, in this scenario, based off of their existing workload, it's okay to go and configure it for two CSS instances to be configured for search and indexing. And then as part of our validations and performance tests, we'll go vet out this assumption. The other part of it is around the APIs. As we transition over to the containerized platform, CPE only supports CWS. It does not support EJB. So that also means that the custom application that they're using, the portal, the customer portal, the vehicles claims applications, if it was written to be using EJB, it will need to be rewritten or updated to use CWS. And that's a pretty straightforward change from a custom application perspective. They're using the Java API, right? It's just a matter of switching the protocol definitions from EJB to CWS. Now, the other implication here is that around the service integration layer. And so this kind of ties back in terms of, okay, well, what are the APIs that Sonnet supports, right? So we have the native Java API that CPE provides. We have CMIS that we also support that has also been containerized. And of course, we have a new cloud-based API, which is Content GraphQL. Now, given their scenario and what they're doing from an API perspective, remember that they go not only access documents, but they also initiate a workflow. So that means that API has to support both content and process execution from an API perspective. So that only kind of leaves us one API endpoint for that service layer, which is the CP Java API over CWS. And the reason for that is that CMIS is purely all content, right? Is generic content-based APIs. Our Content GraphQL, it currently only handles folders and document-centric APIs. We're going to eventually add more or expand that API. So definitely the only integration or the API that they'll be able to use is the C Java or the CP Java API over CWS. So this is what the migration plan looks like, right? So on the left-hand side, you'll have the traditional on-premise environments. And then on the right-hand side, we have our new modernized Sonnet platform on OpenShift. Now, definitely what happens here is that the load balancer will direct traffic to each of those platforms. Remember that each of these custom applications is using a specific navigator desktop. And so the load balancer will be able to know how to redirect traffic based off of that URL, as well as the customer portal or the service integration layer. It knows how to redirect traffic to the right application or endpoint that needs to be updated for that custom application. Now, one thing to keep in mind is that in this scenario, if they are an existing Sonnet customers and they are moving to OpenShift, and you already have OpenShift in-house or licensing or subscription perspective, you can use and deploy your custom applications or any other applications into that cluster. However, if you trade up your existing Sonnet licenses to Cloud Pak for automations and you leverage the OpenShift subscription that comes with Cloud Pak for automations, you cannot deploy any other workload other than the Cloud Pak for automation component. So this custom application would need to be deployed and running somewhere else and not in the same OpenShift cluster as Cloud Pak for automation. So that's a key point, right? The other point is that this custom application has to be modernized. And one way for you to do that is to leverage a tool called Transformation Advisor. The transformation advisor will be able to take and inspect existing WAS applications and help you build a new modernized version of applications based off of Liberty and a Docker container. And so when you run that application through Transformation Advisor, it will actually give you a server.xml file that you can use to go deploy that application into Liberty, as well as a Docker file for you to use to build the Docker container to deploy into OpenShift or a Kubernetes platform, right? So as part of modernizing that vehicle's claim customer portal applications, we can use Transformation Advisor to build a new version of that based off of Liberty in a Docker container. And you also notice that under Navigator, we will be able to address the EDS plugin by deploying that same EDS plugin into OpenShift under Navigator container, right? And be able to query those backend customer data that they have internally in a separate database system, right? So this is kind of a way for us to be able to look at how do we run parallel environments and redirect applications to ones that has already been modernized and running on OpenShift, as well as still be able to service existing applications that has not been modernized and still running on traditional on-premise and be able to access those same data, right? And so this is what we call a parallel environment, and this is kind of the basic architecture. How do we do that? Couple things. This is just kind of a little background information in terms of when you go deploy these components, what are the resource requirements and the number of replicas in terms of how do we provide HA, as well as the ability to leverage dynamic scalability or dynamic auto scaling capabilities, right? And this kind of really ties into the overall sizing of how do we size OpenShift and how do we size FileNet for this deployment. And so you'll notice here that these are the minimum requirements for OpenShift. We require 3 masters, 3 etcd, 3 infrastructure, and 3 application nodes. And then from a FileNet deployment perspective, right, we go back and take a look at the utilizations that we had and be able to come up with what we would think would be the new sizing for the containerized platform. So definitely leveraging your existing sizing and usage that you currently have in production, then translating that into OpenShift is a great way to start, right? And then this is kind of what it looks like. How do we place those pods out, the CPU allocations for each of those pods, as well as the memory, and how that correlates into the infrastructure sizing for those worker nodes, okay? And then integration. Integration is really important because potentially you might have other IBM products or FileNet integrations that you currently have. And some of these things has an impact whether or not you can deploy those and leverage the containerized platform. And so enterprise records, DataCamp, ICC for mails, those all supports containerized platforms. And then of course, business automation workflow, and eventually where do we looking at from a roadmap perspective in terms of delivering containers. And so this is the current state, not necessarily our future state, so some of these things will change. So now that we have all the planning and architecture done, best practices, right? So deploying, it's really, if you want to increase your success rate, your first deployment should be a net new scenario. Understand how containerized version of FileNet works, how it gets deployed, leveraging CI/CD pipeline integrations. In fact, I was just on a previous call with another customer around how do they tie in and incorporate their move to FileNet containers and OpenShift into their CI/CD pipeline. Performance and scalability, right? You know you have a production environment, but remember you're moving to a new architecture, you have a different sizing, how we allocate those pods and sizing. So it's good to go run through those performance and scalability tests to make sure that you vet out those things. Having a good understanding of OpenShift, right? This is all new to you. Definitely you want to deploy each of those deployments into their own separate namespace. Understand what the security context constraint is, the network policies, and definitely auto-scaling is one of the key features of moving to Kubernetes, dynamic workloads. But before you turn on auto-scaling, run your performance test to have a good understanding of your baseline. And also, if you're moving towards the Cloud Pak for automations, understanding what your VPC licensings are before you turn on auto-scaling. You don't want to be overutilized and out of compliance from a licensing perspective. And then lastly, Prometheus, application monitoring. Take advantage of the Kubernetes platform and Prometheus to gain better insights into your environments or your FileNet deployment environment. And leverage the application monitoring that comes out of the box with our FileNet containers and the Prometheus alerting capabilities. Definitely you want to use dedicated storage and ingress over routes. Definitely ingress, you're going to have better flexibility versus routes, but it really depends on what you're trying to achieve. You always want to make sure that you specify resource limits. Our operators do this automatically. You can continue to tune it. And then, of course, being JVM aware, right? We don't set JVM heap size anymore. And that's also because our Java is container aware. And so it is based off of the resource limits that you set. And so that's one of the key things. And then, of course, lastly, how CSS load balancing works, right? So this is kind of CI/CD pipeline. Definitely a lot of our customers who are moving towards containers and Kubernetes are incorporating automations. Automations with Kubernetes and containers means repeatability and stability of your deployment, right? Then lastly, what does it mean if you want to move to AWS and migrating to there? So a lot of the some of the initial questions that we were kind of talking between myself and Martin is understanding what your cloud strategy is. And of course, understanding what your current state and your desired state is will help you define the migration strategy to AWS. And if you already know you're going to move to AWS, one of the key things that a lot of our customers are doing now is to slowly migrate content into AWS to AWS S3, right? If you already know you're going to move to AWS and you're going to run and store content into AWS, then you can do some of this initial work now as you move contents into the AWS S3 ahead of time before you actually move all the software into AWS. That means less content you need to migrate and less things you have to worry about from a migration perspective. Those are the kind of things that you want to start considering. And of course, what services you want to leverage will kind of dictate in terms of what the new architecture is. You want to be purely native in AWS, or do you want to have a mixture of both, right? And definitely it really comes down to, from an operational perspective as well as from a cost perspective and your DevOps expertise, okay? And this is just kind of a summary, and then we are done. Any questions?
Yeah, Kevin, that was really good information. I really appreciate your time here. Lindsay, can you ask the questions that have popped up?
Yeah, and thanks to everyone who submitted questions throughout the webinar. So the first question is, if there is no modernization of custom applications, what would be the timeline to stand up a containerized FileNet P8 system?
So, so what we're probably talking about is purely just migrating, and so that kind of entails whether or not you have an existing Kubernetes environment already in the house, and how much expertise you already have. And so that definitely shortened the timeline a little bit, and definitely, I mean, I have a customer that started off with their dev environments. They were able to migrate to a containerized platform within a couple of weeks. And that's because they were still going through a learning phase in terms of understanding OpenShift and what it means to deploy containers. And then as they moved into the hardware environments, those timelines gets less and less. And definitely, if you're talking about on-premise, that's going to be definitely easier. It's just a matter of reattaching and pointing those things to your existing data. So really, it comes down to two things, two major factors. Whether or not you have a Kubernetes environment already in-house and you already have expertise. And then, of course, how familiar you are with the FileNet containers and the whole Kubernetes environment.
Great. And then another question, can the FileNet container work with IBM GPFS Spectrum storage?
So yes and no. As long as if we're talking about purely GPFS, which is mounted as NFS, then yes. If you're talking about more Spectrum Protect, then no, because we don't have the IBM Spectrum Protect client software installed in our containers.
Great, thank you. And then what are the features or components of FileNet that are not currently supported in containers?
So that's a great question. We actually have a KC link in terms of when you should be adopting containers. So we kind of mentioned a couple of things in this slide. One of them is EGB, right? If you're using custom applications that are tied to EGB, you're going to have to update those to UCWS. And then VMM, we don't support VMM because Liberty doesn't support VMM. And then, of course, going back to the integrations of the other auxiliary components that you have in place.
Awesome. And it looks like we have time for one last question. Will there be any quick starts in addition to the one for AWS?
So yes, we have FileNet AWS Quick Start already available. We kind of published that at the beginning of this year, and there is plans to look at doing a quick start for Azure. I can't say when, but that's one of the next quick start we're planning to do is to do one for Azure.
Okay.
Awesome.
Go ahead, Lindsay.
Oh, no, go ahead. I was just going to pass it on over to you.
Okay, so that's all the questions that have come across. If you have any other questions, feel free to reach out to us. I think the information was given out at the beginning, but I also want to thank all the people who have joined today, and also thank you to Kevin from IBM for joining today and giving us such good information. I guess that'll do it for today. We finished right on time. Appreciate your time, and feel free to review this presentation that'll be available on our website shortly. Thank you for joining again, and that's it. Thank you.
Thank you.